Hey everyone, welcome. This is the next video for polynomials. We're just going to be going over polynomial operations today. Nothing in this video is really that new. We're going to go over adding, subtracting, and multiplying with polynomials. All right, so this won't be very long. So adding polynomials, all right, is like literally just combining like terms, okay? I mean, the fact that like these are grouped together doesn't really make a difference at all with what's going on. So you just have to, find the like terms, okay? 3x plus x, that's 4x. And then 11x minus 5x, that's 6x, and 4 minus 13, that's negative 9. So that's the answer. Okay, that's literally all you do. Subtracting is just slightly more difficult because you have to remember that you are distributing the negative sign. So what I like to tell students to do with subtracting is actually distribute that out and write everything how it would become. So basically all the signs flip. And then once you've done that, then combine like terms. So, you've got y and 5y, so that's 6y. And by the way, we normally will write things in standard form. So like we want to put the 4y squared minus the 2y squared in front of it. And then you got minus 3 and minus 1, so that's minus 4. And then you've got the y cubed in front. So that would be the answer here. So just don't forget about that, because if you just start combining like terms with all this stuff, well, like you're subtracting that stuff. So that's why all the signs flip. So I'm not going to do C and D. All right, I want you guys to try C and D, okay? Multiplying, okay? Multiplying is a little bit longer, all right? Multiplying is just like, doing the distributive property a bunch. So like this example right here, anytime, you've got an exponent, that means whatever is inside the parentheses is being multiplied by itself. So this isn't like with the exponent rules when you could distribute the exponent in. You can't do that with addition, all right? And you'll see why. It gets a lot more complicated. What you have to do is that like double distributive property, right? So 3x squared times 3x squared, that's 9x to the fourth. So here the exponent rules are kind of coming into play because we've got the 2 times 2 makes x to the fourth. 3x squared times 1, that's 3x squared. And then 3x squared times 1, that's 3x squared again. And then 1 times 1, that's 1. So now once you do that, you'll have to combine like terms again. So you've got 9x to the fourth plus 6x squared plus 1. Remember, when you're combining like terms, the exponents don't change, right? You're just adding the coefficients together. So this would be the answer here, all right? So if you just distributed the exponent down, then you're missing this middle term right there. So make sure that you don't do that. Do I want to do all these? I don't know. This one, if you got 3 different things, okay, you're going to have to like basically treat this as its own problem, and then its answer, you'll multiply by x minus 5. So you'll do your double distributive property to start. So like x times x, that'll be x squared. X times 4, that'll be 4x. Negative 3 times x, that'll be negative 3x. Negative 3 times 4, that's negative 12. We can combine like terms there, so that'll be x squared plus x minus 12. And then you still got the x minus 5. All right, so now you'll have to do the same thing again, right? So x squared times x, that's x cubed. X squared minus times negative 5, that's negative 5x squared. X times x, that's x squared. X times negative 5, that's negative 5x. Negative 12 times x is negative 12x. Negative 12 times negative 5 is plus 60. So, it's a little bit longer. You should have 6 terms here. And again, you will have some combining like terms to do in the middle. So that'll be negative 4x squared. That'll be negative 17x plus 60. Okay? And so that would be your final answer. So hopefully that made sense. G, G is just like E, except, you've got 3 of it. So you have like x minus 5 times x minus 5 times x minus 5. And so you'll have to multiply that out. So G and H are just like F. Well, H is basically like that part of F. So I want you to try G and H on your own. All right, see if you can get the right answer. The last thing here, I'll go through this one, but, we can make these as long as we want. It's just going to make it more complicated, and make what you have to do it more. But you're not really, like, doing anything different. Like, this is going to be like a 3 by 3, so you're going to have, like, 9 terms after you do this. But okay, so y cubed times y to the 2nd, that's y to the 5th. Y cubed minus 4y, that's minus 4y to the 4th. Y cubed times 5, that's plus 5y cubed. Now go with the middle. Negative 2y squared times y squared, that's negative 2y to the 4th. Negative 2y squared times negative 4y, that's plus 8y cubed. Negative 2y squared times 5, that's negative 10y squared. You might not have enough room in this box, so you might have to add. No, we should be good. 3 times y squared, that's plus 3y squared. 3 times negative 4y, that's negative 12y. And 3 times 5, that's 15. So we got all that. Now we do have combining like terms to do. So we have negative 4y to the 4th and negative 2y to the 4th. That'll be negative 6y to the 4th. 5y cubed plus 8y cubed, that's plus 13y cubed. That's negative 7y squared. And then minus 12y plus 15. Okay, and so that would be your answer. All right, so this is a quintic polynomial. All right, so that's it. That's basically all it is, and that's all your practice is. So go ahead, you can work on your practice. If you have any questions, let me know, and have a great day.